Hello, I'm Mark, and welcome to my Unreal Engine tutorials on how to build a physics-based static thruster setup for your Unreal Engine games. So in this video, we'll be starting the process of building out a physics-based vehicle movement component so that we can start creating vehicles that can fly around our Unreal Engine games. So as you can see here, what I've done, we've got our simple cube here, and I'm flying it around. I'm actually controlling it using the thruster system that we're going to be building. So all the movement is actually being done through thrust points. So as you can see, I can tap the yaw keys, and then we're yawing, we can move forward, and then I can put some lateral thrust in. So, and as you can see, now my lateral thrusters are weaker than my main thruster. So as you can see, I can move left and move right. So we can also move up, and we can also move down. And then we can also, like I said, in addition to yawing it, let's make sure that we're going on an upward trajectory. I can also pitch it using thrusters and roll it using thrusters as well. And eventually, we'll want to get, with a little bit of thrust control, and then if we can later on, we'll also build in some input control and rotation control. We should be able to then start building things closer to that battle cruiser, as you see in the background, and have that thing move around in a zero gravity environment using thrust and rotation, using our thruster system. So as always, we've got a lot of work to cover today, so I'm just going to go ahead and stop this, and I'll just minimize the demo. Okay, so let's get started. So if you're coming from the networking videos series, then this should kind of be old hat, since we're going to be using those same design patterns that we used in the networking to be able to start integrating our setups into our vehicle simulation component. So all I've done, I did a little bit of pre-prep, and in that pre-prep, I went ahead and if I come over here real quick. So in the last set of videos, we went and created our object, our object traits here, which is going to be our object input and state, and then all the structs that are going to be needed to move that up and down the network. And then we also created our object simulation component here. So what I've done is, in the interest of time, I just went ahead and recreated that, but under vehicle movement traits and vehicle simulation component. And I've left these kind of empty right now, so we can go ahead and fill out all the information we need into this code as we move through the tutorials. So let's get started. So I'm going to go ahead and get started on the vehicle movement traits first. And so within here, we're going to be adding in the inputs that we're going to need for our thruster system, as well as the simulations, as well as any state information that we want to track while the vehicle is moving through space. So to do that, let's start off with the input first. So here's our vehicle simulation inputs, and I'm just going to go ahead and bring in the traits that we want, or the inputs that we want to manage. So I'm just going to bring that over. So as you can see, we're going to be having throttle input X, throttle input Y, and throttle input Z. So this will manage the inputs along those linear axes. And then we're going to have yaw input, pitch input, and roll input. And so those, for this tutorial, those are the 6 inputs that we're going to be managing in our component. And then I'm also going to add a reset function down here so that we can reset these inputs if need be. So as we learned from various other tutorials within the series, once we use an input, we'd like to try and we want to make sure that we're consuming it. That way we don't have any dirty data in there. And then, so also, but since there's no value, I'm not defining any values here as initializers, I'm just going to go ahead and just run this in the constructor. So as you can see right now, so on the constructor, we'll just reset the inputs, and that's just going to call this function down here, which will allow us to reset any of these input values if we need to reset them. All right, and that should do it for now in the vehicle simulation inputs. As my tutorial series on vehicle movement goes, we'll probably add some more inputs in for various other inputs that we might need to put into, to control other vehicle types. But for now, that should cover most of the bases. All right, so now we're going to move down to vehicle simulation state. And before we do the vehicle simulation state, unlike in the other vehicle, in the other tutorial where we just put a couple of pieces of information in here, I'm going to add another structure up top first. And that struct is going to be for us to, I'm just going to go copy this over and just make the API change. I think that might be easier. So I'm just going to bring this over. And because it's using a different API label, I'll just move that there. All right, so again, this is a direction state, and this is actually going to be used within our vehicle simulation state. And so within here, we've got our axis, speed, and acceleration. And this is information that can be very useful, especially when building additional systems that we might want to do automated input management on later on. So again, because I'm dealing in three-dimensional vehicles, we're going to be tracking this along 3 dimensions. So I decided to go ahead and create my own struct and manage. That way I can manage all 3 axes. So we'll be able to track the speed on the up, right, and forward axes. And again, we've just got a overloaded constructor here, which is going to be taking the axis direction in. And it's going to put that information in there. So just set the axis on the constructor, and then we can provide it to update the data. And then we have an update function. So this is information that's always going to be constantly updated, both on the game thread as well as on the physics thread, since we'll be working on 2 threads. All right, so now that we've got that done and we've got the inputs, I'm just going to go ahead and minimize this to maximize real estate. We've now got the vehicle simulation state. So this is our state component. And within here, first off, I'm going to just go ahead and update the constructor. And I'm just going to add. So here, we're just going to go ahead and create these. And might as well just add those properties down here too. So there's our forward state, right state, and up state, and when this is created, we're just going to go ahead and set them up for forward, right, and up vectors. And then additional information that we're going to need to be tracking, and I'm just going to go ahead and grab this for now. I'm just going to go ahead and park this in. So I'm going to make sure, I want these to be read-only from the blueprint, so that we can then use these for other purposes if we needed to track information or use this information from the blueprint. But then some of this information right now I'm just going to keep kind of to itself. So here we've got world transform, so we want to know what the world transform is always going to be. We update that. World velocity, we got the angular velocity, world angular velocity, and I'm actually going to expose those as well while we're here, because this could be, actually they already are exposed. So world velocity, angular velocity, this is again information that could be very useful for being able to counteract certain controls from the blueprint. World center of mass. And the world velocity normal, we've got the local acceleration, local g-force, as well as the local velocity, and then we're also going to be updating the last frame vehicle local velocity as well. So this is all the information that we're going to be managing within the state. I'll just pause it there real quick. And then I'm just going to add 2 more functions to this. And again, we're going to have an update state GT and an update state PT. So the GT is on the game thread. This is a way to update the state from the physics thread. So I'm just going to include those two functions there. And the only reason why they're slightly different is because on the game thread we take the body instance, on the physics thread we're going to be taking the handle. Alright, so now that we got this done, let's go ahead and just finish up the implementation. I'll just expand this. So we have the reset inputs down here. So I'm just going to go ahead, say potential fix, which will kick us over to our implementation. As you see, I haven't filled out any implementation yet. We'll get to that when we, a little bit later. But we'll go ahead and start working on those new structs that we just created. So reset inputs. So to reset the input, all we're going to be doing here is taking our throttles and our pitch inputs, and we're just going to set them to an initial value, and those initial values are 0, 0, 0, 0. So that's all we're going to do there. Alright, so that should all be happy now. That's all we're going to do there. And then in the direction state, I'm just going to hit the update here. And I'm just going to add an extra include. Might as well just put that in there right now, since we're going to need it. We're going to need the when we start filling out these other empty functions, we're going to need the physics proxy single particle physics proxy.h class. But for now, let's just come down. So we've got the reset inputs. I'll just minimize that since it's done. And then we just need the update. So for update, all we're going to do is we're just updating the information here, which is going to be our axis. So that's going to take the world transform axis and put that in there. And then with speed, we're going to be taking the world velocity and the transform axis. We're going to do a dot product, which is on the f vector, which is a function on the f vector. And what that's going to do is that's going to give us our speed along this axis. And then we're going to also get the local acceleration. And that local acceleration will be based on the axis that we want as well. So those are the three pieces of information we're going to be constantly updating within that struct. So, alright, so that's the updates on the direction state. So I will now minimize that. And then lastly, we've got update state GT and update state PT. So I'm just going to go say potential fixes, and I'll just go grab both of these while we're here. Alright, and then just updating the state. I'm just going to go grab everything that I need. So they're very similar. Like I said, the only difference is just where it's coming from. Is it the target instance or is it going to be the handle? So here again, so on tick, we're going to be updating all of this information, and then here you go. Here's our update function being called here for our forward state, right state, and up state directions. And then again, doing something very similar, just from the handles perspective down here. The handle's a little different because we have to go and create a transform, where here we can, on the instance, we can use this get Unreal World transform here. So slightly different ways of getting that access to that information. But then once we've got this information, then we can start to fill in all the information, all the additional information that we need. All right, so that should do it for the input and state. So let's go ahead and start filling out our network functions. So to do that, we have a little bit of a chicken and egg conundrum that we need to solve for first. And so to do that, we need to come over to our physics of vehicle. And we need to go ahead and set up our state. So again, when we were working when we were doing some of the networking stuff, we needed to have a reference back between the state objects that we're sending up and down the network as to and the component that is being used. So to do that, we need to first reference our states. So I'm just going to bring those over. So as you can see here, we have the vehicle state simulation input and simulation state, and that's coming again from our vehicle movement traits, which we've got over here. And then in the vehicle movement traits, we need to then go ahead and reference back up here back to our vehicle movement component, because we are going to need some pointer references in our apply and build data. So to do that, we'll just go ahead and say pound include, and we'll say this is what under simulation vehicle component.h. All right, so now we're ready to start this off. So this is our vehicle net viz move state. So we have one for state, and then we have one set for input. So we'll start off with state first. So let me just go find all that stuff. Where are we? All right, here we are. So to do this, we just need to go and bring over this. So this is how we're going. This is how Unreal Engine is able to use its component to figure out, to be able to map things. So apply data. This is just going to say, take everything that's currently in this vehicle net physics movement state, which is right here. So here we have a reference to our vehicle simulation state up here, but we need to get that back out of the component. So again, we have this circular logic. So in order to take this movement from the network and pass it into the components, this is how that's going to do. So that's applying the data that's coming along the network and back into the component. And then build data is going to be doing the reverse. And again, we want to check to make sure we actually have a network component. And then that network component is then going to be cast to our physics mover. And then we'll take the state and put it back into this. So this is what we build to then send this back up the network. All right, so we've got apply data and build data cache. So that's pretty simple. Then decay data for state, we really don't need to worry too much about this. So I'm just going to go ahead and just do that. We'll just put a simple math in there, but we're not going to do anything with it. And then net serialization, again, not really going to do too much with it, but we do need to return a true. So we're just going to return what's up here, override it, hit true. Interpolation for state, we're just going to leave it empty. And then merge data, and we're just going to call this empty function, but it's not going to do anything. So... but that's all the setup we need to do here, and we should be good. So now we're just going to do the physics move inputs. And again, it's very similar to the state, setting that up, but now we're updating the movement inputs instead of the movement state. So again, apply data. And then we're going to go ahead and build the data. So we're going to fill those in. And then decay data. So this is something that we are going to go and work with. So I'm just going to go bring this over real quick. So our decay data. So again, we're just calculating how we're going to, what the rate of decay, or what we want our rate of decay to be. And then what we've got is we have our movement input on the x-axis. So what we're going to do is we're going to take a lerp between what the value is and 0, and then that's the rate of decay that we're going to be doing our lerp on. And we're going to do it for X, Y, and Z, as well as the input, pitch, and roll. All right, so now we've got that set up. We can minimize that one. Net serialization, again, we're going to be just taking some information and moving it, serializing it down the network. So again, we're just going to serialize all of this into this archive. And then I'm just going to go ahead and out success equals true, and then we'll return true as well. All right, so that should do it for serialization. Then we have interpolation. So again, this is a little bit. Again, I'm just taking the basics from the networking, which is what we did there. And then all we're doing is we're just setting it up for our input X, Y, and Z. And again, we're just doing a lerp between the min and the max and the lerp factor. So we're calculating our lerp factor based on the frame rates. And then here we have our yaw, pitch, and roll as well. And again, and that's all we need to do there. And then merge data is pretty simple. All we're going to do is we're just going to then call again the interpolate data. So now that we're set up, we shouldn't need to come back into this again for a while. So that's all set up for all of those inputs. We're good. Okay, so I'm just going to go ahead and move over to the component. That looks good. All right, so next up we need to create our thruster setups. So to do that, I'm actually going to move back to the Unreal Editor, and I'm going to do a quick compile, make sure everything looks good, and then if everything looks good, then we can then go ahead and create our simulation structure for our thruster setups. So I'm just going to come over here, hit the compile. Waiting for it to compile. All right, we have a good compile, so that's good. All right, so now let's move on and do our thruster setup. So to do that, I'm going to create a new class. So I'm going to come over to our project, under content, C++ classes, public. So I'm going to put this under simulation, and I'm actually going to keep it at the root. So we have object and vehicle, but these are just, this is where I'm going to keep my simulation code. So under here, I'm going to say new class, and I'm going to go to none, empty C++ class, since I'm going to be making these as classes and structures. And I'm just going to then hit next. And then for this, I'm going to go ahead and set this up real quick. Let me go find. There it is. So I'm just going to go ahead and call this simulation configurations. And it's going to stay at this root level under simulation for my code, again under public. And then I'm just going to hit create and let Unreal Engine and Visual Studio create me a boilerplate class. Come on, there it is. All right, well, we'll have to go and recompile that real quick. All right, there it is. And I'll just reload it, and that's then going to give me my simulation configuration there. And under simulation, I've got my CCP file. All right, so now we can go ahead and start creating our simulation code. So I'm just going to go ahead and just keep this class here. I'm not going to do anything with it. But it's just, I'm just going to keep it up here for now. So first off, let's get some includes up here. So to do that, I'm going to just need one include, and that include is going to be for the simulation physics. Oh, nope, don't need that one actually. The only include I need right now is actually the one to generate the H file. So, and that's referencing here and here. And again, I'm going to keep this at the bottom of the stack. So I'll just keep that clear. Simulation configuration.h. All right, so now that that's done, the next thing I'm going to use for our configuration, our thruster setups, I'm going to bring in two enumerations. And this will help this is going to be for thruster setup and input mappings. So the first one is going to be for input mappings, and I need to make sure that we've got my blueprint on here, since it's going to be referenced in the blueprint as well. So enum blueprint type. So this is going to be how I'm going to be able to map a input from the blueprint into the system. So we've got throttle X, throttle Y, and throttle Z, and then we have roll, pitch, and yaw. So that's that enumerator setup, and then this is going to tell me how I want to set up the thrust direction. So so we can map it, and then we can say which direction it's going in. So again, on the and since these are static, it's going to be either on the X, the Y, or the Z axes. So I'm just going to save that. All right, next I'm going to say we're going to need to know what direction we're going to go in. So what I'm going to do is so for this setup, I'm actually going to break it up into substructures, subcomponents. So it's a little bit more, I guess, object orientated. So now that we've got this, and I do need to change that, so I'm going to grab this real quick and change that API to the right project API. All right, so those are the enumerators. So for here, the first thing I'm going to be building is a subcomponent of the static setup, static thruster setup, little tongue twister there, is the force direction configuration. So this is going to allow me to say on this thruster, this is the direction I want to go in. And what we're going to do is we're going to add a thruster axis, which is our enumerator here. So we can say this thruster or this thrust point that we're creating on our mesh is going to be in this direction, and by default it's going to be in the X direction. We're going to add a little bit of offset, so we can also offset the pitch, the roll, and the yaw. So it's not, so this is the main direction, but we can also give it so that it's slightly angled when it fires, if you need that slight angle offset. And then we also have the is negated. So, and this could be very useful when creating thrusters that are going to be doing pitching, rolling, and yawing. You might want to say, well, if I fire it, it's going to go in the X direction, but there could be a second thruster that's set up on that same input, but you might want to go in an opposite direction. So that's kind of how we can then set that up. And then finally, we have this little get thrust direction that will allow us to go ahead and get that direction. So let's go ahead and get the implementation done. So I'm going to say show potential fixes. That's going to bring us over here. Just going to minimize that since we're not doing anything with those. And let's go ahead and just fill out that implementation. So I'm just going to go bring this over real quick. All right, so for the implementation, let's just make sure it's color-coded. So again, it's just, this is the direction that we want to fire the thrust in. So this is how we're setting up. So first off, we're going to go and check to see which direction it is, and then we're going to set that direction, that vector direction. So if it's static X, it'll go on unit X, static Y will go on unit Y, static Z will go on unit Z. Again, these are little static functions that are coming off the vector. So there's a lot here, and so those are the ones which we're taking. So that's X, Y, and Z. So that gets the general direction. And then this is what we're going to do if we want to then add some offset. So this will then take that direction and rotate it. So to rotate it, we're going to create a rotator, and then we will take the angle offset, whatever angle offset is, and then on that rotator we're going to then change it to this quaternion. I can't really pronounce it. This quat. And once we get that quat, right, then we can say rotate vector. And again, this is then going to take that rotation. We'll say rotate vector, take the direction. So this is the vector that we want to rotate based on the rotation that we've created here. And then that should give us a, and then we're just going to take that and replace this, replace the result of the direction with that rotated vector. And then again, we have the is negated. So if we want this to be rotated and then go in the opposite direction, we'll then go ahead and just take the direction and then multiply it by -1, and then that should reverse it. And then we're just going to return the direction back. So, and that's all we're doing there. So, but this is what you need to do if you want to rotate the vector. So, and again, we're taking our pitch, yaw, and roll, creating our quat, and then we just, off the quat, that's when we'll pass that in. Pass in what we want to rotate based on what we set up here, and that's the output we're getting as our rotated vector. And we'll be doing a lot, we'll be using this a lot as time goes on to make sure that our thrusts are going in the direction that we need to go, and that we're updating those directions so we get a smooth transition. All right, so that's get thrust direction. So the next structure we need, come back. So we've got thrust direction. So now we need to know where our thrust point is on our struct. So this will allow us to put a thrust point at a specific location. So I'm just going to bring this whole struct over and again just change the API tag so we can get rid of the squiggly. So I'm just going to minimize the thrust direction. So this is the location. So this is our force location. And again, it's another struct. I'm building these structs just to kind of keep everything together and kind of separate those concerns out. So that's everything needed for direction. This is going to be everything that is going to be needed for location. So, so I'm setting this up so you can either put a bone or a socket name in there. And so what we'll do is we'll take that bone and socket name and then find the location on the mesh based on the bone or the socket name, and then go ahead and get its X, Y, and Z location. And then we also have this location offset, and because we're working, if you're working with third-party meshes and you don't necessarily have access to the files, you may need to tweak the actual location off that just to make sure you try and balance out the thrust points. So this gives us a little bit of fine-tuning as well. And again, these are and then I'm just inlining the set force location. So what we'll do is we'll just take the socket bone name, and so here we have a private vector, which is the socket or bone location, and then that's what that's going to do. So we'll be calling this from the vehicle movement component when we do our setups, and it will then be getting the location, putting it into the private here, and this is, I've set this up as a private variable. And then when we get the location, we'll just say get the location and then add the offsets to the location. So if this is empty like it is, then we're just going to be using offset only. But if we have a socket or a bone, then we'll just add the offset from that as the starting point. And that's all we need to do for the force location. And again, since they're very simple, I just inlined them right here. So just keeping it all together. All right, so that is the location. Next, we're going to need how much force or thrust we want our thrusters to output. So I'm going to go ahead and bring this over. I'm just going to take the API real quick and convert it. So again, we have, let's color code this. We've got our physics thrust force. So this is everything needed to generate the actual thrust. And so what we have here is so I've got a curve. If you want to use a curve, so curves could be very useful if you're working in space games, you probably don't need it. But if you're working in games where you might have a plane or a helicopter flying through the atmosphere, right? You may want to degrade the amount of thrust based on your altitude. And so here you could then say, as I get higher in altitude, instead of having a total thrust of 1,000,000, right? It might start to degrade and degrade and degrade as you get higher and higher and higher. Until you get to the ceiling, where you probably want to then set your thrust to 0, because the amount of air going through the engine is just not enough to create enough thrust anymore. So that's what you can use the curve for. But if you just want to do something simple, we've got our max thrust here. I'm just setting it to 1,000. And then we have a multiplier. And the reason why I have the multipliers here is because when we start working with physics bodies, right? Some of those physics bodies could get very heavy, and suddenly now we're talking millions of units of thrust versus thousands of units of thrust. And so this can be a good way of just lopping off some of the zeros here to make this number more manageable. And then lastly, I'm going to put a thrust condition %. And this is something that could be useful in gameplay. If you wanted to have a game where, as you're if you want to shoot out an engine, right, then you can degrade the amount of thrust coming out of that engine based on the amount of damage that engine is taking. And so this is where you just reset this from 100%. And as you can see, I've got a clamp here, so we can go from 100 down to 0. And once it hits 0, you're getting 0 thrust out of it. Once you and various in-betweens. And then we've got our function here to say get max thrust. So let's go ahead and fix this one. Here, definition. So here, again, just some simple equations. So again, what I like to do is, if I'm using a curve, I'll check we'll take the curve over the default. So we'll check if there's a curve, then what we're doing is we'll just take the thrust condition. We'll access the curve object. We'll get the float value based on the altitude being passed in. And this could be an altitude if it's a game in which you're flying. It could be a depth, so then it would be a negative altitude, right? If you're going underwater and you want to simulate submarines or mini-subs going through the water using a thrust system. And then then we just take the value coming off the curve, multiply it by the multiplier, and that's why I've got the parentheses here. Do this first, and then we'll multiply whatever that is by the condition. And then if we're just using the static value, max thrust, it's the same thing. We're just not floating through the curve to get that information. All right, so I'm just going to minimize that and minimize that. Hit save. All right. And then finally, after all of those subclasses or structures are being created, now we can create the actual structure which we want, which is the physics static thruster setup. And again, I need to just grab this API tag. And so within here, let's just make sure everything's color coded. So here again, it's just I'm creating a tag name. So this is something, so you could have lots and lots of thrust points. And then if you want to have a way to then say, adjust this based on damage to an engine, or if you needed to turn a thruster on or off here, you'd need to have a good way to find it. So and that's what this is. It's just so you can put a tag in there. So if you wanted to add a function into your vehicle movement component to look these things up to change some values during the course of a gameplay, you could do that. Enable and disable. So this is a way to turn a thruster on or off completely. Then we have, again, this is the mapping. So this kind of goes all the way up to here. So this is how we're going to, this is the input that we're mapping this thruster setup to. And then we have the thruster direction. Then we have the thrust points. And then we have the thrust force. And then off that we have the set throttle. So again, we're taking the input in, and then we're just going to make sure we clamp it to either between -1 and 1. And then we have the set world altitude. So if we're going to be using altitude to determine if we have a curve, right, we want to use that altitude to determine what that force is going to be. That's how we can set it here. And again, it's just altitude and input. And again, these two variables, I've just made them private. So they're sitting down here. All right, so then the only thing we need to do now is just set this function up. So I'm just going to go show potential fixtures, open it up. And let's go ahead and define that. Okay, I'm just going to bring this over real quick. All right, so all we've done here is through all of those various systems or subsystems to help configure it, all we're going to do here is within the get force, we're just going to go ahead first check to see if we're enabled. So if we turn the thruster off, we're going to bring back a 0 vector. Otherwise, if the thruster is enabled, then what we're going to do is we're going to take the inputs, multiply that by the get max thrust, which is part of our thrust force system. And then what we're going to then do is we're going to say get the thrust direction, which is part of our thrust direction system up here. So, and that should do it for getting our thrust force from our configuration. So that is all of the simulation structures that we need to create our static thruster setup. And I'm just going to minimize that real quick. And that's all the implementation code that we need. Okay. So now we should be ready to come over to the vehicle simulation component and then start bringing it all together. And I think I'm going to pause the video here, and we will pick this up in video number 2 on setting up this component so that we can then take advantage of our thrusters. So if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel. And I will see you hopefully in part 2. Cheers. Bye.